Welcome to BUILDCHAIN. 80% of Europe's buildings will still be in use in 2050. Many are aging, and the data we have about them is often lost or outdated. BUILDCHAIN is here to change that, creating a secure, decentralized platform to connect building data, improve transparency, and shape a more sustainable future for Europe's building stock. The BUILDCHAIN project has clear objectives. We aim to create a decentralized data ecosystem using blockchain to ensure trust, transparency, and traceability. We work to improve energy efficiency, cost-effectiveness, circularity, and climate resilience by connecting advanced digital technologies, from digital twins and IoT-based sensors to blockchain-enabled data platforms. We want buildings to be safer, healthier, and more comfortable by using data-driven modeling tools and optimizing building functions. We strive to improve the management of large building portfolios, helping owners and operators make better decisions. And finally, BUILDCHAIN is exploring a new tokenized economy around digital building logbooks, opening the door to innovative value creation opportunities for the entire construction ecosystem. The BUILDCHAIN project addresses 12 use cases that reflect real challenges in building management and renovation. These range from lifecycle analysis and carbon footprint computations, U1, to structural health monitoring, U3, U5, earthquake and climate proofing, U4, post-catastrophic interventions, U9, and construction economics, U10. One of the key use cases is use case 11, management of deep renovation workflows. This is where the Deep Renovation tool is focused. It helps project managers and municipalities plan complex renovation projects with less disruption, better scheduling, and clearer data integration across the entire process. The pilot aims to demonstrate how the BUILDCHAIN platform can improve earthquake resilience and reduce the carbon footprint of buildings. Data from a large portfolio of school buildings owned by the municipality of Florence will be logged into the platform. This includes in situ survey data, material properties, seismic performance, and safety risk indexes already collected through previous research by University of Pisa with the collaboration Municipality of Florence. The Deep Renovation tool, focused on use case 11, management of deep renovation workflows, will be applied in this pilot to simulate renovation scenarios, assess user disruption, and support decision-making for the municipality. The pilot will demonstrate the benefits of using the BUILDCHAIN platform and the Deep Renovation tool for managing a large population of buildings under a single authority. By providing data-driven insights, the platform will support better decisions on adaptation and intervention strategies, helping the municipality of Florence plan renovations based on priorities and available financial resources, while minimizing disruption to students and staff. Use Case 11 is directly connected to Pilot 5.4, where we are applying the Deep Renovation Workflow Management tool. This tool, developed in Work Package 4, Task 4.1, and led by RINA-C with contributions from Clio, supports the planning and execution of complex renovation projects. It works hand in hand with WP2 and WP5 activities, and its results will be delivered in Deliverable D4.1, covering months 12 to 31 of the project. Hello everyone, welcome to the demo of the Renovation Management Tool. Today, I'm going to walk you through what the Deep Renovation Management Tool, or Deep RINA-C, is and how it works. Deep RINA-C is a digital tool developed by RINA to support the planning and management of deep renovation activities. It's designed specifically to help assess and minimize disruption through simulation, analysis, and clear visual reporting. The tool enables project managers to organize renovation workflows in an efficient and strategic way, ensuring occupant comfort, operational continuity, and transparent stakeholder communication throughout the renovation process. Who is this tool for? Primarily for project managers, to plan and schedule renovation activities, while also visualizing their impact. Facility managers, to track disruption related to utilities, movement, and overall building operations. Final users, to gain a clear view of schedules and access limitations. Administrative and planning teams, to optimize and reduce disruptions using data from the preliminary schedule. So, how do we describe Deep RINA-C? It's an intelligent renovation workflow management tool. It helps structure and adjust schedules in a way that minimizes disruption during renovation. By analyzing timelines and forecasting potential disruption, Deep RINA-C allows both project managers and facility managers to make informed decisions, ensuring a smooth execution with minimal impact on day-to-day activities and building users. Now, let's have a look at the interface. On the main page, there's a Get in Touch button that opens a direct email contact form. There are login areas for both client users and administrators. At the bottom, you'll find info about RINA and the fact that this tool was developed in the context of the BUILDCHAIN project. You can also manage users from this admin panel. You'll find active users such as RINA and the Municipality of Florence. Currently, we have one main client account, the Municipality of Florence. You can also view all the simulations that have been run so far. For example, we have a large number of site preparation simulations. As you know, preparation is essential before starting any renovation, and structural activities are often more impactful. Now, let's go into the assessment section. Here, all renovation scenarios are listed. Typically, we analyze at least 2 per case study to allow for comparisons. Let's focus on Scenario 1 for the Vittorio Veneto School. Clicking Edit allows us to see how calculations were performed. For instance, the area around windows and flooring was calculated, and the square meters of insulation required were automatically computed. You can do the same with BIM models, but AutoCAD is also fully supported for early-stage quantification. Let's view the simulation results. You'll see that renovation activities focused mainly on the ground floor. The overall renovation duration is displayed in days, with each activity broken down. Site preparation takes about 3 days. The most time-consuming task is facade insulation, which lasts 16 days due to the cavity fill process. In this case, most disruptions are internal or physical, because this project, handled by the Municipality of Florence, focused on construction-type interventions. Pilot 4 was an educational building, so the property type and user group were clearly defined, in this case, Italy. This section also shows you the average KPIs. Because the renovation is structural, most disruptions are internal, especially in classrooms and teaching zones. This scenario was marked as complete on the 3rd of the month. You can also analyze overlapping activities. For example, you can do reinforcement work while simultaneously installing facade insulation. The tool lets you schedule these in parallel. Let's take the window and door replacement activity. Here, you'll see duration, construction discipline, detailed steps, like removing old frames, installing new frames, and adding shades. This activity has mostly internal disruption, especially near the window zones where tools and materials are placed. What are the key features of the tool? Renovation scheduling, disruption impact analysis, heat maps and interactive timelines, automated reporting, a fully web-based interface. You can even perform a preliminary count without a BIM model. The tool also provides recommendations for each activity. For example, confirm HVAC systems are operational after window installation. Keep internal doors closed to reduce noise and traffic. Avoid placing furniture near the renovation zones. These are intended for facility managers, who can share them with building occupants. This is the main interface of the tool. You also have access to a Gantt chart, which clearly displays activity start and end dates, sequence and overlap of activities. Back on the home page, when logging in as a client, you get a different dashboard. Now let's look at how properties are created and managed within the tool. In the admin interface, users can define various property types, such as disruption impact categories, building topologies, e.g., educational, residential, commercial, geographical properties like country or city, client organizations, e.g., municipalities or private firms. These properties are used to tag each renovation project, making it easier to categorize and analyze data across multiple simulations. To begin creating a new project, simply click on Create Project. Start by entering a project name, a unique code, and then select a property from the drop-down list. This drop-down includes all properties you've already created. Next, choose the project owner and set the start date. Once all required fields are filled in, click Create to launch your new project. Keep in mind, you must first create a property before assigning it to a project. That's it, you're now ready to manage your project efficiently and with ease. Once your project is created, you can launch a new assessment. In the assessment, you'll be able to select specific renovation activities and input the required quantities, tailored to each zone of the building or urban area to be renovated. This helps generate a structured renovation plan, directly linked to real needs on site, with no need for a full BIM model at this stage. You'll also be able to view the same planning data as seen in the admin panel, such as estimated durations, work phases, and dependencies, though downloads remain restricted to admin users for consistency and data protection. This tool is a game changer for public authorities. Cities like Florence can use it to anticipate and coordinate large-scale renovation works, ensuring minimal disruption to urban life. Even before detailed designs are in place, it enables early planning through a preliminary Gantt chart, identifying possible conflicts and synergies across multiple interventions. It's a powerful step toward smarter, more resilient cities, and toward making urban renovation efficient, transparent, and user-driven. The visualization of results through the API will be part of WP5, using the DKG BUILDCHAIN UI platform. However, within Task 4.1, we have already established the connection and successfully published the results into the DKG Node 1, feeding the BUILDCHAIN Knowledge Assets Bank. Thank you. This is clearly an innovation action that is fully aligned with the digital building logbook and the overall scope of BUILDCHAIN.